Okay, hi everyone. This is a quick lesson on precision and accuracy, what those terms mean, and what the difference is between them. So, precision is a measure of how closely grouped measurements are to each other. So, if you look at the first two targets up there, we're using a metaphor of shooting a gun at a bullseye at a target. And the true value, the target that you're hitting for, trying to hit, is the bullseye, the dot right in the middle. So, if you look at the first and second targets, you'll notice that the shots are all both grouped closely together. So those are both precise measurements. If you look at the third and fourth targets, they're not grouped closely together. Those are not very precise measurements. Accuracy is a measure of how close the measurements are to the true or accepted value. So the first target shows that all the shots hit the bullseye, and that would be very accurate shooting. The third target shows that the shots are kind of close to the bullseye. They're spread out, but they're kind of close to the bullseye. That would be reasonably accurate shooting. So let's take each one of these. The first one is both accurate and precise. The shots hit the bullseye and they're closely grouped together. What that means is that the gun, the sights on the gun, and the gun was calibrated properly. It shot where it was supposed to shoot, where the shooter was aiming for, and that the shooter was a good shooter. He knew how to shoot the gun. So it's both of those things together. If you look at the second one, that's precise. They're grouped closely together, but it's not accurate. That would be an example of the shooter being a good shooter, but his gun isn't calibrated properly. The sights on the gun, the things that he uses to aim the gun, are off. They're crooked, maybe. And so he's hitting the same spot all the time, but it's not the right spot. And that would be more the fault of the gun, not of the shooter. The third one is somewhat accurate. So the shooter there is a pretty good shooter, or he's an okay shooter. But that's more so the shots are accurate, but they're not precise. They're spread out. And then the fourth one would be neither accurate nor precise. They're spread out and they're not close to the bullseye, close to the target. So a lack of accuracy can be due to the instrument not being calibrated properly. So the second target there, again, the shooter is shooting at the same place every time, but it's not the right place, which would probably be the fault of the gun. If you're in chemistry class, you're not shooting guns, your scale is not calibrated properly. So you're constantly getting you're putting a 5 gram mass on a scale, but you're constantly getting a reading of 6 grams with different 5 gram masses. That would tell you that you're reading the scale properly. The scale just isn't measuring properly. So lack of precision can be due to the instrument not being, or excuse me, a lack of accuracy. Very precise measurements, they're all in the same place, but they're off from what they should be, is usually a case of the scale not being, or the instrument not being calibrated properly. Okay, the lack of precision is due to an error by the person doing the measurement or the technique used. Sometimes in physics class, what you might have done is drop the ball from the bleachers and had people measure how long it took to fall. Well, that's not a very accurate way of measuring, and it's not very precise. Some of the readings will be too high, some will be too low. Even though the stopwatch you're using might be a very good instrument, may be very accurate, it's hard to time accurately when people are dropping a ball from the bleachers. Some of the readings too high, too long, the time is too long, some the time is not long enough. So you don't get a lot of precision. The readings that you get are all spread out. So you see two numbers here, a 3 and a 3.000. Now, in math class, those two numbers would be equal to each other, but not in science. We measure precision of a measurement by the number of digits we use to express the measurement. So the numbers below have the same value, but the number on the left shows a precision of plus or minus 1. In other words, that number may actually have been 2.5 that was rounded up to 3, or 3.5 or 3.499 to be more exact, that's rounded down to 3. So that's a big spread between 2.5 and 3.499. So that's not a very precise number. The number on the right, 3.000, while numerically the same, is telling, in science, is telling the reader of that number that the measurement was done to a precision of 0.001. So we can't simply express numbers with any number of decimal places we want. There's a set of rules that you're going to learn shortly of how you determine how many places after the decimal you're allowed to express a number. So accuracy is measured by the percentage a measured value differs from the actual value. So percent error is the measured value minus the actual value over the actual value times 100%. The numbers on the top, the measured value, accurate, some people might write actual minus measured. It doesn't matter because you see that there are absolute value signs there. And the absolute value symbol means that the answer will always be positive, whichever way you do the subtraction. So that doesn't really matter. So here's a quick example, pretty simple example. Assume that the measure value of a length is 4.75 and that it's known that the actual value of that length is 4.87 meters. So you simply plug those numbers in, and your measured value has an error of 2.46%. And that's how you measure the error in a, that's how you measure the accuracy in a measurement, is by using percent error. Precision is a measure of how closely grouped measurements are. Precise measurements are not necessarily accurate, as we saw with the bullseye. If a scale is not calibrated, adjusted properly, several 5-gram objects could all show a reading of 6 grams. This would be precise, but not accurate. The measure of precision is called standard deviation. Standard deviation is challenging to calculate by hand. I'm going to have you do just one example of it on your own just so you see how it's done, but you will not have to do this regularly in class. It's usually done on a spreadsheet, so on Excel, so you don't need to do this by hand. Okay, so find the average and standard deviation of the two sets of numbers below. So we have a set of numbers 19, 20, and 21. We have a second set of 10, 20, and 30. So as you know, you take the average of numbers by adding the numbers together and then dividing by how many numbers you have. So 19 plus 20 plus 21 divided by 3 gives you an average of 20. If you do the same thing to the 10, 20, and 30, you also get an average of 20. So both of those sets of numbers have the same average, but you can clearly see that the set on the right is more spread out than the set on the left. So how do we express that, the fact that it is more spread out even though they have the same average? And that is the standard deviation. Okay, so both sets have the same average, but it's clear that the set on the right is more spread out, meaning it has less precision. So here we go. This looks a little messy. I'll just explain it to you. Again, this is not something you have to know how to do by hand in class, but let's just talk about what the process is. You don't really have to deal with this until you get to a statistics class. So we take the three numbers x, so that's the first column, 10, 20, 30. Then you take the average. The average of those three we already said was 20. So you put that in the second column. And then you subtract the first column minus the second column. 10 minus 20 is negative 10. 20 minus 20 is 0. And 30 minus 20 is 10. Now you square that third column. And you get my negative 10 squared is 100. And then 0. And then 10 squared is 100. And then you add those three numbers in the fourth column together. That's the summation sign in the fifth column to get 200. The next step in the process is you find something called the variance. And you don't have to remember that term. You'll have to when you get to statistics class. So you take that number 200 that you got at the end, you divide by the number of numbers, and it gives you the variance here of 66.7. To find the standard deviation is the square root of the variance. So you take the square root of 66.7 and you get 8.2. We'll talk graphically at another time what the 8.2 represents, but for right now, the bigger the number, the more spread out the numbers we were working with are. The bigger the standard deviation, the more spread out the numbers that you had in your set were. Let's do the same thing with the other set of numbers. And you see I did the same thing in the left column. It's the three numbers, 19, 20, 21. You end up with the average number in the second column. You do the subtraction, then you do the squaring, and you end up with your summation in the fifth column as being 2. So we take that number 2, divide it by how many numbers we had, which is 3, and you get 0.667. You take the square root of that, and you get your standard deviation, which is 0.82. So the larger standard deviation means the data is more spread out. The smaller standard deviation means the data is less spread out. And that's what standard deviation tells us. So that concludes our quick lesson on accuracy and precision.